Assalamu alaikum everyone. In today's class, we will be discussing the molecular formula and empirical formula. Now, the molecular formula is defined as, or you could say the molecular formula shows the actual number of atoms of each element in a compound. And the empirical formula shows the simplest whole number ratio between atoms of different elements in a compound. Now let's take an example and see what we actually mean here. So for example, C4H8, this is known as butene. Now the molecular formula of butene is C4H8. Why? Because this formula shows us the actual number of atoms of each element in a compound. In reality, when we look at a butene molecule, we see 4 carbon atoms and 8 hydrogen atoms. But what about the empirical formula? Now, for the empirical formula, what we have to do is basically a good simple way to deal with it is that take the molecular formula and form a ratio between your different, you could say, atoms of different elements. Over here the ratio is 4:8. What you simply have to do is simplify this ratio. And how can you do that? By finding out the largest integer with which both the numbers of atoms of different elements are divisible by. In this case, it is 4. So I can simplify this ratio as 1:2, can't I? Well, there you go. That is your empirical formula. This is going to be CH2. Okay? So think of it as finding the largest integer both numbers of atoms of different elements are divisible by. And then just divide the numbers, the actual number of each atom, the actual number of atoms of each element by that largest integer. Or you could just think of it as a ratio that we need to simplify. Now let's look at some examples. Here we have a molecule, and I'll name it later. But what do you think will be the molecular formula for it? Well, let's see. I have 1 hydrogen and 2 hydrogens. And how many oxygens do I have? 1 and 2. The molecular formula for this compound would be H2O2. Why not O2H2? Because if hydrogen is present in a molecule, it is always written first in a covalent compound I'm speaking of. This is naming of compounds, or you could say when we are writing the formulas, that's a separate topic, so I won't be covering that here. And what would be the empirical formula? Well, let's see. If I form a ratio between hydrogen and oxygen, the ratio becomes 2:2. This is the actual number of atoms. Let's simplify it. I think the largest integer divisible by both sides is 2. So I have 1:1 left. So the empirical formula would be HO. Oh, okay. Moving on. Let's see another example. Okay, so let's look at this one. How many carbons do I have? 1, 2, 3, 4. So this would be C4. How many hydrogens do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So H10. And then how many oxygens do I have? 1. So it would be C4H10O. Now think about this for a while and tell me what is the empirical formula. Feel free to pause the video. Okay, so in this case, let's first form the ratios. carbon to hydrogen to oxygen. The ratio is 4:10:1. Now in this case, if you note, we can't really find a largest integer by which all three of these numbers will be divisible by. In fact, that would be just simply 1. Many of you might ignore this oxygen part and consider only this C4H10 and simplify it to 2:5 and then bring in the 1 later on. But you can't basically do that. Why? Because to find the empirical formula, all of those numbers, all numbers of those atoms or different elements need to be divisible by the same integer. So over here, when we have 4:10:1, I can't really simplify the 1 of oxygen further, even if I can simplify the ratio between carbon and hydrogen. And therefore, the empirical formula of C4H10O will be C4H10O. By the way, this is butanol, it's an alcohol. So there you go. From here, we can actually draw a conclusion, and that is, for some compounds, the molecular formula is equal to the empirical formula. So remember that this can happen. Let's look at another example. Okay, so this one looks a bit complicated. So let's do this step by step. So 1 carbon, 2, 3, 4, 5, 6. So this is C6. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. H12. And then how many oxygens do we have? 1 here, 2, 3, 4, 5, and 6. That's C6H12O6. That is actually your glucose molecule. This right here, my friends, is glucose, your monosaccharide. Okay, let's simplify this now. Forming the ratios, I have C ratio hydrogen, basically carbon ratio, hydrogen ratio, oxygen. That is 6:12:6. What is the largest integer by which we can simplify these ratios? That is 6. I hope you got it. So it would be 1:2:1. Okay, just simplify the ratio. So the empirical formula would be CH2O for the glucose molecule. Now let's look at this example. What do you think? The molecular formula. 1 carbon and we have 2 hydrogens. So that looks like CO2, carbon dioxide. Now what do you think would be the empirical formula? I hope you guessed it this time. We can't simplify CO2 further because when we write down the ratio, it's already 1:2, which cannot be further simplified. And therefore, the empirical formula will remain CO2. Another example of how for some compounds, the molecular formula can be equal to the empirical formula. Okay, let's look at this example. Now for this question, we'll write down the molecular empirical formula for both of these compounds. Looking at the first one, I have 1, 2 carbons and 1, 2, 3, 4 hydrogens. That makes it C2H4. Now let's look at this one. We have 3 carbons and 1, 2, 3, 4, 5, 6 hydrogens. That makes it C3H6. Now what would be the empirical formula? I hope by now you don't really need to write down the ratios like I was doing before for the previous examples. I hope you can do it mentally now. The empirical formula is simply CH2. And the empirical formula for the second one is also CH2. So what conclusion can we draw over here? The conclusion that we can draw over here is that different compounds may share the same empirical formula. That's the conclusion from here. Every compound has its unique molecular formula, but different compounds can share the same empirical formula. that we just saw right now. Now, the previous examples, all of them encompassed us going from, finding out the molecular formula and then jumping to the empirical formula. So we moved in this direction, right? From the molecular formula to the empirical formula. So in this case, we not only learned how to write down the molecular formula, seeing a diagram, but also once we have that molecular formula, how do we move towards the empirical formula? Now in this scenario, we will talk about how we will move from the empirical formula towards the molecular formula. What I mean by that is, if you have been given the empirical formula, how will you end up with the molecular formula of the compound? The first thing that you need to know for any recipe are the ingredients, right? So for any relation, for example this one, we first need to know the kind of tools that we must first have. Now for you to move towards the, from the empirical formula to the molecular formula, you actually require two things. One of them is the empirical formula itself. Firstly, you need that. And secondly, you need the MR of the compound, or the molecular mass of the compound. Now, let's look at the steps. I like writing down the steps because I believe it makes things easier for the students. So the first thing is, after you have noted the empirical formula and the molecular mass of a compound, find the MR of the empirical formula of the compound. So that should be your first step. Once you know the the molecular mass of the compound, and once you know the empirical formula, you first find the molecular mass of the empirical formula of the compound. Okay, now I'll put an example side by side so that it becomes easier to understand. For example, the empirical formula of a compound is CH. No, actually not CH2 because we've done that before. How about CF2? And the MR of the compound, or the molecular mass of the compound, is 200. Okay, so first of all, you need to find the MR of the empirical formula of the compound, which in this case would be, let me use another color, 12 plus 19 into 2, which makes it 50. So I'm actually finding the molecular mass for the empirical formula, that is CF2. The second step is that you need to divide the MR of the actual compound, okay, with or by the MR of the empirical formula form of the compound. Now what do I mean by that? What I mean to say is, we will divide the molecular mass of the actual compound by the molecular mass of the empirical form of the compound. What would that look like? That basically means that I'll divide 200 by 50, and that gives me 4. Now what does this 4 mean? This 4 right here is what we call as N, and I'll get to that later. Okay, but the third step over here, I'll write it down here. The third step is multiply the integer, okay, with empirical formula. Remember, the number you will get by dividing the molecular mass of the actual compound by the molecular mass of the empirical form will always be an integer. It will always be an integer. If it is not, you definitely did something wrong, and most probably is the first step. Okay, so let's do that now. So CF2, I will divide all of that by 4, and this gives me C4F8. So there you go. That right there is your molecular formula. I hope I can clarify this further. So we will look into some more questions. Okay, question 1. Calculate molecular formula of a compound with empirical formula P2O5 and molecular mass 284. So I want you to pause the video, use the 3 steps and calculate this answer by yourself. Okay, so step number 1, what was that? That after noting the empirical formula and the molecular mass of the actual compound, we would find the MR of the empirical formula. So what would be the empirical formula for P2O5? Actually the MR of P2O5. Well, let's calculate it. That turns out to be, well, 32 plus into 2 plus 16 into 5. That turns out to be 144, I believe. No, actually it's 31 into 2 plus 16 into 5. That turns out to be 142. How did I do that? The AR of phosphorus is 31, so multiply that by 2, and then oxygen is 16 into 5, and that's 142. That's our first step. The second step is dividing the MR of the actual compound by the MR of the empirical formula. So this would be 284 divided by 142. That makes it 2. As you can see, I got a whole number. It needs to be an integer, remember that. And now that I have my n, I can simply multiply it by the empirical formula. So 2 into P2O5, and that gives me P4O10, and there you go. That is your molecular formula. Okay, so now we will do the last question. Calculate molecular formula for compound with empirical formula C6, I believe H13, and molecular mass 170. Again, the first step is, let's find the MR of the empirical formula. So MR of C6H13 would be 6 into 12 plus 13. 6 into 12 plus 13. And that ends up as 85. The second step is dividing the MR of the actual compound with the MR of the empirical formula. So 170 divided by that gives me 2. As you can see, my n is again a whole number. It needs to be an integer. Now multiply this n with your empirical formula, that is C6H13. This ends up as C12H26. It's an alkane. Now, let me just for a moment write another thing that may clarify something. The molecular formula, remember, would always be a multiple of the empirical formula. Okay, this n can be 1. That could be the case for, let's say, CO2, when the molecular formula is equal to the empirical formula. It could be equal to 2. It could be equal to 3, 4, 5, 6, and so on and so forth. So remember, the molecular formula is actually the multiple of the empirical formula. And therefore, we are interested in finding out that integer or that multiple or that integer with which, when we multiply the empirical formula, we will end up with the molecular formula. I hope this video helped you guys. I tried my best to clarify everything. Well, for now, this is it. I'll be back with another video, inshallah, very, very soon. Till then, if you have not subscribed to our channel, do click that button down below. And if you want to get to know more about our ongoing sessions, the link to our Instagram page is down in the description box. You can click there and find out more. Till next time, Khuda Hafiz.